Welcome to the Project Iron Boomerang, the Australian East-West Rail and Global Smelting Parks project. This presentation sets out the work done during the rail pre-feasibility study. The presentation will show the data that was acquired for the project and the key assumptions made. Outputs from the corridor analysis will be reviewed, and we'll finish with a flyover of the favoured corridor. The data used for the corridor identification was sourced to cover a 400 km wide band across Australia. It was then broken into 15 sections, each approximately 200 km in length. The digital terrain model came from the USGS website. Information on roads, railways and watercourses was obtained from Geosciences Australia. Australian topographic series maps were then overlaid on the terrain model. Boundary data for mining leases, national parks and Indigenous lands were brought into the project database. Each of these data sets were compiled into Quantum on a common XYZ Cartesian coordinate system. Underpinning the study were a number of key assumptions. These included the geometry required for the heavy haul rail and unit construction costs for a range of activities. Land use data was assessed to identify potential conflicts between the corridor location and specific land use. Once the data had been compiled, the quantum system was run to sweep the whole area for favourable corridors. In this example, the clumping of the blue alignments indicate low-cost alignments that comply with the required rail geometry. These low-cost corridor options were subsequently correlated together with corridors from the other 14 200 km sections and made into an overall corridor options network map. Each alignment generated in Quantum is fully developed in 3D, so comparisons in plan, profile and cross-sections can readily be made. Section by section, a network of favourable corridors were identified. This slide shows diagrammatically the node points between each of the sections in the first 1500 km of the project. Here we can see the main corridor options for one section of the project in central Queensland. The topographic maps were used to identify key constraints that would have to be more fully considered in subsequent stages of the project. The settlements of Cuyuna and the Cannington mine are shown in this detail. For each alignment generated, raw construction costs were calculated. However, to estimate the full project costs, allowances had to be made for additional items such as working remote areas, drainage structures and river crossings, design standards for crossing sandy sections, avoidance or land mitigation costs for environmental areas, and project overheads. Including these allowances, the anticipated rail project costs totalled $6.5 billion for the favoured Northern Corridor. This flyover has been compiled using Google Earth overlaid with one of the favoured corridors identified in the pre-feasibility study. It starts at Abbot Point in central Queensland, where one of the two smelter parks would be located. The thin blue line is the existing rail alignment between Abbot Point and the Riverside mine at Goonyella. From here, we pick up the favoured corridor as it heads west, past the Moranbah National Park, passing to the north of Winton, and then onto the first service point at Cuyuna. From Cuyuna, the corridor passes 2 established mine sites, and then across the Barclay Tablelands and on into the Northern Territory. 200 kilometres north of Alice Springs is the settlement of Tea Tree. It is anticipated that this will be the next service point on the corridor. From Tea Tree, the corridor continues westward into the state of Western Australia, where a third service point will need to be established. Once across the border, the corridor is in a very remote desert area. Ridging sandhills will be a key consideration in this section. Passing to the south of Ruddell National Park, the corridor approaches the iron ore region of the Pilbara. This is the proposed location of the second smelter park. Mount Newman iron ore mine can be seen relative to its location. Existing rail infrastructure would be utilised to transport the iron or steel product to Port Hedland for export. In closing, Project Iron Boomerang represents a truly visionary concept and opportunity. East-West Line Parks is utilising innovative methods in establishing the business case for this project, as witnessed by the application of the quantum system. We look forward to your continuing interest in the project.